All right, hello everyone. Welcome to Algebra 1B for week 7, learning how to factor completely. For week 7, make sure you're going through all the sections in our textbook, 1 through 5. Make sure you're taking notes, you're doing practice problems, watching the videos on this video, but also on your paper pencil problems. And let me know if you have any questions as you're going through any of the assignments for this week. Here's what we're going to be learning. More on factoring. If I give you a trinomial, can you recognize if it's a perfect square trinomial and factor it into binomial squared? If I give you a polynomial, can you use all of our factoring techniques and be able to factor it all the way down? We have lots of different techniques we've been learning so far. We're going to learn how to, if I give you a polynomial, use factoring by grouping as a method of splitting it into factors. Finally, doing a little bit with a word problem and seeing how to use factoring to begin to solve equations. Okay, let's start with something we have already learned. Do you remember how to multiply the following? We got 2x minus 5. It's a nice little binomial, and I'm going to square it. Well, squaring means I have two of them, right? Multiplied by itself, so we need to take 2x minus 5 and multiply that by itself, 2x minus 5. There's two of them for the square. Well, by multiplying binomials, we've seen how to use the distributive property. Each term in one polynomial has to multiply each term in the others. So this 2x term has to multiply this 2x term. We've got 2x times 2x plus this term also then has to multiply the other term, the negative 5 term. So we've got plus 2x times negative 5. Now we move to the other term here. This 5 term multiplies the 2x. So we've got plus negative 5 times 2x. And finally, the negative 5 multiplies that negative 5 to make plus negative 5 times negative 5. There we go. That's the distributive property. That's a little review on multiplying binomials. When I put it all together, we've got 4x squared plus negative 10x plus another negative 10x plus 25 when I just multiply everything all out. And then you'll notice we can combine these middle terms to get 4x squared minus 20x plus 25. There we go. That's multiplying. That's squaring a binomial. But when we're trying to go in reverse with factoring, so multiplying gets me to the trinomial, but now I want to be able to undo that and get back to where I was before I multiplied. So we can do the same thing if we recognize certain patterns in our perfect square trinomials. For example, let's see what we got here. I got x squared minus 10x plus 25. To go backwards, I need to have this first term be something squared. Well, that's x squared. That's easy to see. But this last term needs to be something squared. 25 is 5 squared. Well, let's see if this works out. I've got a negative 10x in the middle, so let me see if it's a special case of being x minus 5 times x minus 5, the same thing twice. Well, I'm going to check that out here by multiplying. X times x gives me x squared. X times negative 5 gives me negative 5x. Negative 5 times x gives me another 5x. And negative 5 times negative 5 gives me plus 25. When I combine my middle terms, look at that. I get right back to where I started with by checking. So this trinomial is a perfect square trinomial that factors into x minus 5 times x minus 5, or it factors into a binomial squared. This factors into this right here. And it's what we call a perfect square trinomial. All right, let's do another one here. This one over here is a perfect square trinomial. Let's kind of see if we can notice the patterns going on. We've got 4. Well, 4 is 2 squared. X, there's my x squared. 81 is 9 squared. So I'm looking at the beginning and the ends, and they're both squared things. I'm like, okay, I like that. So let's see if it actually is 2x plus 9 times 2x plus 9. And I got the 2x from right there because it's squared and the 9 from right there. And it's all plus because I have a plus for the middle term. I'm going to check it out by multiplying. 2x times 2x is 4x squared. 2x times 9 is plus 18x. 9 times 2x is going to be plus another 18x. And 9 times 9 is 81. If I combine my middle terms, I do get 4x squared. 18 plus 18 gives me 36x plus 81. So multiplying it out, it checks out. These are the same binomial. So I'm going to write it as a binomial squared. 2x plus 9. There's two of the same ones, so it's squared. And this factors into that. There you go. There's a perfect square trinomial. It's again one of those special situations as you're factoring. You may not necessarily recognize right off, but if you see again the first term and the last term are some of those squared numbers that we work with, just see if it happens to factor nicely into that. So here we go. We've gone through factoring. Let's sum up everything we know so far with factoring. If we have a polynomial, the first thing we always want to look for is, can we factor out the greatest common factor? Whoops. Let me say that again because I was confusing there. Can we factor out the greatest common factor? What I mean by, if I take this example right here, what's in common with all three terms? Well, in this one, I can factor out a 3 because 3 is in common with 3, 9, and 18. I can factor out a factor of x. And what I have left when I divide out my 3x and move it out into the front is I have x squared minus 3x plus 6. So there we go. That's factoring out the greatest common factor. So the very first thing we learn, and it's the first thing you want to check for on every single polynomial you're working with. And then we learn how to factor trinomials, again, 3 terms, with a leading coefficient a of 1. That means there's just a 1x squared. And we learned how to look for what b is. B is negative 2. It's my middle term coefficient. And c is negative 15. There's b, there's c. And if I look for two numbers that multiply to c but add to b, that tells me what it's factored into. My two numbers are going to be 5 and negative 5 and 3. Negative 5 times 3 is negative 15, but negative 5 plus 3 equals 2, negative 2. And so all that factors into x minus 5 times x plus 3. There we go. That was kind of an easy trinomial. We learned how to find the difference of two squares. So we've got two terms. 49 is 7 squared. 100 is 10 squared. And if they're being subtracted, we can really easily write it as 7x minus 10 times 7x plus 10. Based on the fact that 10 times 10 makes 100 and 7 times 7 makes 49. And there we got the x times x makes x squared. And we just covered the last one is perfect square trinomials. Again, 64 is 8 squared. 9 is 3 squared. We double check to make sure things add up right in the middle, but this one is going to be 8x plus 3 squared. That binomial is squared. This is what we've learned so far with factoring. And one of the things you want to do as you get better and better with factoring is to check that, make sure you're factoring stuff completely down all the way. Before we dive into a lot more of that, let's do some solving equations. So you're going to have a section on continuing to see how factoring we can solve equations. So last week we did the zero product property where we could factor, and then you set your binomials to 0 and you try to see, well, what makes it equal to 0. We're going to do that same thing. Now that we've got more factoring methods, we're going to continue to use the zero product property. So let's take this situation right here. We've got x squared minus 7x is equal to 30, and I want to know, all right, what value does x have to be to make this thing equal to 30? The problem is I got x squared and I've got an x to the first power, so I have to use some other methods to solve it. We're going to use factoring. Here's my steps. We're going to run through this all the way. The first thing is I can't use the zero product property until it equals 0. So I'm going to subtract 30 from both sides and get this as x squared minus 7x minus 30 is equal to 0. That's my first step. Now, step 1 done. Now I'm going to look to see, can I factor the trinomial on the left here? Well, this is a trinomial, 1, 2, 3 terms. It's an easy one. The leading coefficient is 1. So what are two numbers that multiply to negative 30 but add to negative 7? My numbers are going to be negative 10 and 3. So this factors into x minus 10 times x plus 3. And there we just factored the trinomial. Finally, to solve this thing out, when does it equal 0? I'm going to use the zero product property. So when does x minus 10 equal 0? And when does x plus 3 equal 0? Well, add 10 to both sides, and you see that if x equals 10 or if x equals negative 3, both of those are cases that are going to cause the whole equation to equal 0. We can check them out over here. Let me get a different color here. Let me check by putting it in. Does 10 squared minus 7 times 10, does that actually equal 30? Well, that's 100 minus 7 equals 30. Yeah, that checks, so that's definitely a solution. Does negative 3 squared minus 7 times negative 3, does that equal 30? Well, that just equals 9 plus 21. Yep, that equals 30. So both of these actually check, and there's your two solutions. Solutions are if x equals 10 or x equals negative 3. That's how we can use factoring to solve equations that we've never been able to solve before, just using everything we learned in the first semester. So again, factoring is helping us tackle and deal with much more complicated equations and expressions. Okay, so factoring completely. We want to get really good at factoring so we can handle more complicated stuff. Sometimes you may need to factor once, sometimes you may be able to factor twice, or even 3 times to factor something all the way down. I'm going to do a couple examples of needing to do a couple steps of factoring. Let's start with this first one on the left here. This is a big mess. 4a to the third minus 16a squared minus 48a. It's a trinomial, but there's some stuff I can do to help myself out here to simplify it. What is the greatest common factor? Well, they all have a factor of 4 between 4, 16, and 48. And they all have a factor of a. So let's factor that out and simplify our lives. If I divide all those out, they all are multiplied by 4a in common, but once I factor it out, I'm left with a squared minus 4a minus 12. Okay, I've factored, great, right? But there's more. What's left is a trinomial. Maybe I can factor that down further. Trinomials with a equals 1. I want to see, are there two numbers that multiply to make negative 12? But when I add them together, I get negative 4. My numbers are going to be negative 6 times positive 2. Negative 6 times 2 is going to give me the negative 12. But negative 6 plus 2 is going to give me the negative 4a for the middle term. So there we go. There is the factored form that's equivalent to all this. I like it. I like factored forms. So there we had to factor out the greatest common factor, and then we had to factor the trinomial. I do a couple steps. Let's look at this one on the right. This is 16x to the fourth minus 81. Well, 16 is 4 squared. I like that. And 81 is 9 squared. But I'm tripped up a little bit by this x to the fourth unless I think about x to the fourth is x squared squared. So I really have a difference of 2 squares. And this factors into 4x squared minus 9 times 4x squared plus 9. You can multiply that back together if you need to check to make sure it does that. And then we're good. We've factored it down, right? Except there's more. Right here, I've got another difference of 2 squares, right? 4 is 2 squared. 9 is 3 squared. And I've got an x squared. So it looks like I can factor that into 2x minus 3 times 2x plus 3. And I still have all of this over there. I can't factor the sum of 2 squares. So that stays 4x squared plus 9. But there we go. I had to do a couple rounds of factoring to turn that into this. There's the factored form of 6x to the fourth minus 81. So hopefully there's a couple examples of how we need to do oftentimes a couple steps of factoring to try and break down our polynomial as far as possible and to pieces to be able to do different things with it. All right, we have one last big topic to hit on for this week, and that is factoring by grouping. It's the last section you're going to work on. And this is the hardest factoring, so you're really going to need to kind of ramp up the last 10 minutes and really focus on what we're going to do. Because factoring by grouping lets us tackle a harder problem. All right, so how do we do it? There's my steps. Let's break down what each of these steps mean and actually do a factoring by grouping problem. First of all, factoring by grouping, this particular method only works if you have 4 terms. If I'm grouping, I need to have 2 groups of 2. If I have an odd number pair, like a trinomial, it's not going to work because I can't get 2 groups of 2. So it only works if you have 4 terms. So let's start with number 1. We're going to form our 2 groups. I would first go through, if you have any subtraction, change it into adding with the negative, just like this. Instead of minus 2x, it's plus negative 2x. Instead of minus 5, it's plus negative 5. What that'll let you do then is everything is now addition. I can put my 2 groups with parentheses and not worry about distributing in negatives or things like that. I can just keep negatives with the numbers. So it ends up becoming 4x to the third plus 10x squared plus, there's a 1 group, plus negative 2x plus negative 5. There's my other group. Okay, 2 groups formed, boom. Once I have 2 groups, I want to, well, like I said here, we were careful with subtraction. But now I want to factor the greatest common factor from each group. So let's start with this first group right here. It's in common with 4x to the third plus 10x squared. Well, there's a 2 in common between the 4 and the 10. And there's an x squared common with my variables. So that factors into 2x squared. But we still have, when I divide out, we still got 2x plus 5 inside the parentheses. All right, let's look at my other group. What's in common there that I can factor, my greatest common factor? Well, 2 and a 5, there's nothing common there, and there's no x, so it looks like a little bit puzzling, but they are both negative. Now, a little sneak peek, my goal is to see if I can factor to have my binomials be the same. Notice this is positive 2x plus 5 right down here. So if I have a negative 2x plus negative 5, I want to take out that negative 1. I want to factor out a negative 1 so that what I have left is positive 2x plus positive 5. And now I've got somewhere in this problem. We factored out the greatest common factor. Here's the fun part. Look for common binomial factors. Think of this all as one term right here, 2x squared times 2x plus 5. And I'm adding to that a negative 1 times 2x plus 5. Well, both of them have this common binomial factor, that I can divide out. They both have a shared 2x plus 5. So let's divide that out and put it in front just like we did 2x squared or just like we did negative 1. But now we're dividing out 2x plus 5. They divide out, and all we have left is 2x squared minus 1. That is a factored form right there. I like it. There we go. There's my factored form solution. This all turns into that and is equivalent to that right there. Same expression, just one open and one factored. That is factoring by grouping. Great, great, great addition, but it does take a lot of steps, and hopefully you followed through all that okay, and you're going to practice some of that this week. So our last factoring technique draws on using factoring by grouping as a way to handle any trinomial that we come across. We've done easy trinomials with a, the leading coefficient, not 1. We're going to learn how to handle any trinomial, even if a is a number like 8 or 3 or negative 16. So let's again review multiplying, because factoring is multiplying in reverse, and just help us see kind of some of these patterns. So if I'm multiplying 3x minus 1 times 4x plus 5, again, multiplying each term out, 3x times 4x is going to give me 12x squared. Then 3x multiplies the 5 to get plus 15x. Then the negative 1 multiplies the 4 to get plus negative 4x. And then the negative 1 multiplies the 5 to get plus negative 5. And I kept everything as addition with a negative instead of putting subtraction. But I think you guys get the idea. That's how I would multiply it. And after I multiplied it, I would see if I could combine like terms, and these middle two terms combine to make 11x. So altogether we'd have 12x squared plus 11x minus 5. So we're good at multiplying. That's multiplied out. Those are the same. But what we're going to do is we're going to go in reverse. We're going to get a trinomial. I'm going to show you how to rewrite it into 4 terms. 1, 2, 3, 4. Notice we'll take the middle term, and we're going to see how to split it back up. And then once we have 4 terms, we're going to use factoring by grouping to get it into factored form. That's what we're going to do for this next slide. We're going to take our trinomial, rewrite it as 4 terms by splitting up the middle term for b here, and then use factoring by grouping. All right, here we go. Follow along, take notes, let me know if you have questions. To go in reverse, take our trinomial. First thing we need to know is what is a, b, and c. Well, in this one, a is 12. It's my leading coefficient. My middle term, b, is 11. And my constant term, c, is negative 5. That's our first step. Check, that's done. We got a, b, and c. Now, this will sound kind of familiar, but I want to find 2 numbers that add up to b, which is 11. So 2 numbers that add up to 11, but they multiply to a times c. I need to count for a and c now. So a times c is going to be negative 60. So I need 2 numbers that multiply to make negative 60. All right, let's think for a little bit on what these 2 numbers are. Multiply to negative 60, but add to 11. Again, start listing out all your factors of 60. 1 times 60, 2 times 30, 3 times 20, 4 times 15, 5 times 12, and 6 times 10. And do any of these have a difference of 11? Well, 59, 28, 17. Here we go. 4 and 15. If I take 15 minus 4, that's 11, or negative 4, 4 minus 15. Those have a difference of 11 right there. One has to be negative, one has to be positive. And the 15 is going to be positive, and the 4 is negative. And that gets me to add up to 11, which is positive, but multiply to make negative 60. There's my two numbers. What do those two numbers do? They let me rewrite my trinomial into 4 terms. Remember, that was the goal? Split this up and get it into 4 terms. That way we can use factoring by grouping. So we got 15x plus negative 4x. There's my two numbers. Notice they add up to whatever b is. But I still got 12x squared. And I still got plus negative 5. There we go. We got 4 terms. Check, check, check. We're good. We're halfway done. Now I can factor using grouping with 2 terms, right? 4 terms, split them up into groups. I already made everything addition. What's in common with this first one? I can factor out a 3 and an x. So this gives me 3x times 4x plus 5. Over here, what do I got in common? I've got another negative 1. So I'm going to factor out plus negative 1. I'm left with 4x plus 5. I'm already happy because I can see my common binomials. So let me switch gears here. So the 4x plus 5 is in common. There's my common binomial right there and there. And when I factor those out, I'm left with 3x and the minus 1. Notice this is what we started with on the last slide. The last slide we multiplied 4x plus 5 times 3x minus 1 to get to this, but now we went through in reverse and factored it back out again. That's how we factor complicated trinomials. Go through this process, find your a, b, and c, find the right two numbers, rewrite it into 4 terms, and once you got 4 terms, we can use factoring by grouping. Okay, last one I want to cover is a word problem. As we get into quadratic equations, as we get into factoring more and more, a common type of application is any sort of problem that involves area. Area involves length times width. It involves square units of measure, like feet squared or inches squared. So it's a direct application for using x squared in equations that have x squared in it. So here we go. We've got a rectangle, has a 50-foot diagonal. What are the dimensions of the rectangle if it is 34 feet longer than it is wide? Any sort of geometry problem, draw a picture. It'll help a lot. So let me draw a rectangle. Let's translate the information we're reading. There is a rectangle. What do I know about it? It has a 50-foot diagonal. Let's draw that in and label it. Diagonal means from corner to corner. This is 50 feet long. What are the dimensions? Now that's getting into width and length of the rectangle if it is 34 feet longer than it is wide. So if we have the width, the length is 34 feet longer, or the width plus 34. So there we go. I'm going to label the width right here W, and I'm going to call this W, but it's 34 feet more than W, so it's W plus 34. So we're using some algebra to relate my length and width together. Okay, now how do I actually go about doing this? How does this help me out here? Well, what we're going to do is how are the diagonals and the length and width, how are these sides of a triangle related? I know it's a 90-degree angle. So if you think back into middle school, you probably learned about the Pythagorean theorem as a way of relating sides together. The Pythagorean theorem says a side plus your other side equals your hypotenuse, the long side, squared. So let's put in what we know. I'm going to put in W for one of the sides, plus W plus 34 is my other side. I want to know, when does that equal the diagonal, 50 squared. There's the equation I need to solve. This would have been an impossible equation a while ago, but now I know some good algebra. I can crunch this thing out and I can deal with all the squares. All right, so let's deal with this. W squared. Now I gotta get it equal to 0 if I'm going to use factoring. So let's get W plus 34. Let's square that out. That's going to be W squared plus 34W plus another 34W plus 34 squared. Ooh, I need to calculate that out here. 34 times 34 is 1156. And that's going to equal 50 squared, which is 2500. It's not so bad. Let's combine like terms and set everything equal to 0 and see what we got now. So W squared plus W squared. It's going to be 2W squared. 34W plus 34W, it's going to be 68W. And 1156, but I'm going to subtract 2500 from both sides because I want it to get equal to 0. So that means I'm going to have a negative 1344 equals 0. Okay, so what have we got? We're combining all of our stuff, right? Think about everything we did so far. We multiplied our binomial squared. We did that at the very beginning of this lesson. We combined all of our like terms. We set everything to 0. Now I'm going to factor this. Already I notice I got a greatest common factor of 2. So I'm actually going to factor out the 2, but since it's equal to 0, I could even divide everything by 2. As long as I divide both sides by 2, I'm going to end up with W squared plus 34W minus, let's see, divided by 2, 672 equals 0. 0 divided by 2 is still 0. Now let's see if we can factor it. It's a moment of truth. How well can we factor this thing out? It's an easy trinomial. I've got W squared, so I know that's going to be W times W. But now I need two numbers that add up to 34, but multiply to make negative 672. This may take you a little bit of time, but let's think about factors of 672. I'm going to divide it by 2 and list out my factors. So 2 times 336. Let's do 672 divided by 3. That's 3 times 224. 672 divided by 4. 4 times 168. I know these are all factors, but I'm trying to find 2 with a difference of 34. These are still really far apart, so I'm going to keep going. 672 divided by 5 won't work because it's not a 0 or 5. Let's divide it by 6. So 6 times 112. It's still not quite there. It's getting closer though. Let's do 672 divided by 8. 8 times 84. Again, I'm just going on my calculator and checking this out. 672 divided by 9. Nope, that doesn't divide evenly. 672 divided by 10 won't work. Let's do 11. Nope, 672 divided by 12. I get 12 times 56. This is getting a little bit closer, but those are 44 apart. And I want them to be 34 apart. So I got to keep dividing. So 672 divided by 14. And here we go. 14 times 48. There's my two factors. Those multiply to make 672. But I need them to also make positive 34 when I'm adding them. So that means I need the 14 to be negative. Okay, we got my two numbers. So these factor into w minus 14 times w plus 48. And those equal 0. All right, we are ready to solve this thing out. I can tell by looking at this now, my two solutions are when w equals 14, that's going to make it 0, and when w equals negative 48. But remember your context. I want to know what are the dimensions of the rectangle. That's kind of my goal in this problem. It doesn't make any sense to say my rectangle has a width of negative 48 feet. That doesn't work. It doesn't fit. So I'm going to actually ignore this. This solution doesn't fit in this problem. And this is my solution, is the width has to be 14 feet. Width equals 14 feet. We just solved that out. If the width is 14 feet, then my length has to be 14 plus 34 is going to be 48 feet. There we go. We worked backwards with some algebra and some geometry and the Pythagorean theorem, and we did a great area shape problem. Hopefully you followed that all the way through and saw how we figured out the dimensions of our rectangle. There we go. Week 7 is all done. We did a lot with factoring. We did a lot with using factoring, tackling more complicated factoring. Hopefully you're starting to get solid at factoring. It's going to take you a while to practice this stuff. Please put in some time this week to get efficient at this, to practice each of these methods, to write down some good notes, to do all the problems, because it will really, really help you later on as you tackle more complicated math the rest of this year and in following years. Let me know if you have any questions or want to get some one-on-one tutoring. Have a great week.